Morning viewers, this is Kasturi Day. Today I am going to start the reasons for chemical activity of an atom. Okay, in my last video I was discussing about the valence electrons, which is determining the valency, how it was determined. Okay, so now I will start with the reasons for the chemical activity of an atom. Why there is chemical activity in an atom, or how an atom chemically can perform. Okay, so these we will discuss. Before that, I will ask you to please subscribe my channel and also do ring the notification bell so that when the new video is uploaded, it will be notified as soon as the video is uploaded. Okay, and if you are a new viewer, please to subscribe. If you are liking the videos, press the like button, share with your friends, and don't forget to meditate before you start your day. Okay, so let us start with the meditation, and just for 1 minute, and then we will start with the discussion. Okay, so for meditation, think of a uh, point of light which is giving you energy. The light rays from that point of light is coming and falling on you. It is energizing you. It is giving you full enthusiasm. You are fully charged to perform in the whole day. You're getting interest. Think that you're getting interest in whatever you do the whole day. You're enjoying that and also becoming successful and becoming happy. Positive before this will increase your week and more than the whole night of the week. So thank you for doing this meditation, and then let's start with the discussion. Okay, so we know that atoms of all noble gases except helium follow the octet rule. So because helium has two electrons, two valence electrons, whereas the other elements, they have uh, 8 electrons in their outermost shell. All noble gases. In all noble gases, they have 8 electrons on the outermost shell, except helium, because it has only 2 electrons in its outermost shell. Okay, that's why all noble gases, they follow the octet rule. Now, among all the elements of these inert gases, there are 6 inert gases like helium, neon, argon, krypton, xenon, and radon. Okay, so 6 inert gases are there. Others are normal elements, not inert, because inert gases means they have the valence electrons, they are closed. Okay, that is, they have 8 electrons in the outermost shell. The other elements, they have less than 8 electrons in their outermost shell. That's why they are not called inert. Now, these inert gases, they are non-reactive as their outermost shells are already filled. So they do not combine either with any other atom or among themselves to form molecules. Okay. They will not combine with any other atom to form molecule, or with any other elements atom to form other molecule. Okay. So their combining capacity is 0, and therefore the valency is also 0. Okay, combining capacity is nothing but valency, so the combining capacity is 0. Okay, so the helium has 2 electrons, that is, it follows the duplet rule. in its K shell, which can occupy a maximum of 2 electrons according to the 2n square rule. Okay, according to the 2n square rule, in the K shell, it occupies a maximum of 2 electrons. Therefore, it is stable like other noble gases, even though the 8 electron rule does not apply in this case. Here, the octet rule does not apply in this case, but its outermost shell is complete, 2 electrons. As 2n square, K shell has 2n square rule. According to 2n square rule, K shell has 2 electrons. So it serves the purpose, it serves the rule. Okay. And that's why it is not, even if it does not follow the octet rule, it is considered as a noble gas. Clear? Now, the chemical activity of an atom depends upon the number of electrons in the valence shell of its atom. Okay, so what happens? The chemical activity of an atom depends on the number of electrons which is present in the valence shell of an atom. If it is 8, that means it is inert. It will not react with any other atom. Maybe it is with the same element atom or with other element atom. It will not react. But if it has less electrons in its outermost shell, then the atom will react with other atoms or the atoms of the same element or of different element to form a compound or a molecule of the same element or a molecule of a compound. Clear? Now, the chemically active atoms have an incomplete octet, that is less than 8 electrons or less than 2 electrons, like in hydrogen, in their valence shell. Okay, that's why these inert gases, they are chemically inactive. But chemically active means they will have less electrons in the outermost shell, less than 8 or less than 2, like in case of hydrogen. Hydrogen has less than 2 electrons in its outermost shell. Okay, so therefore they can actively participate in chemical activities. Here, the atoms valence electrons. Any atom's valence electrons, that is the electrons in the outermost shell of an atom, contribute to the formation of molecules. Okay, if it has, I will come later on, if it has 1 electron in its outermost shell, it will give away that 1 electron to other atom and it will form an octet and it will form a compound, a molecule of a compound. Okay, and combine with other atom to form a molecule. Then again, if it has say 7 atoms, it will take 1 atom to form the octet. Like that, it will form a molecule. Yes. So like that. Okay, according to the octet theory of valency or electronic theory of valency of Russell and Lewis, the rare gases have a stable electronic configuration. Okay, according to octet theory of valency or electronic theory of valency of Russell and Lewis, who gave these theories, so the rare gases, that is the inert gases or the chemically inactive gases, elements, they have a stable electronic configuration because their octet is full. Their outer valence shell is full. Okay, that's why they have a stable electronic configuration. The atoms of other elements, they combine as they have incomplete valence shells. As they have incomplete valence shells, they will combine with other atom of other element or of the same element to form a molecule to attain a stable configuration of the nearest inert gas. It may be octet rule or duplet rule. Following the octet or duplet rule, they will form a stable configuration. Try to form a stable configuration by completing their valence shell, as their valence shell is incomplete. Okay. Now, this is achieved. How can this be achieved? By gaining electrons or by losing electrons or by sharing electrons with our atom. Okay, of the same element or other element. I told you, if it has 1 electron, it will give away that 1 electron to form the octet and to form a molecule. Okay, and if it has 7 electrons, it will gain 1 electron and it will form a octet, okay, and this will form a molecule, okay, or it can share also. Okay. Now, the number of electrons gained or lost or shared to attain the octet or duplet in the outermost shell gives the combining capacity of its element or its valency. How many electrons has been shared, or how many electrons has been lost, or how many electrons have been gained, that will be the combining capacity of the element or of valency. If it loses one electron, then the valency will be 1. If it is gaining one electron, its valency will be 1. Okay. If it is losing 2 electrons, its valency will be 2. If it is losing 1 electrons, then its valency will be 2. Okay. If it is sharing 1 electron, then also its valency will be 1. If it is sharing 2 electrons, it will be valency will be 2, like that. Okay. Now, this redistribution of electrons results in the force of attraction develops between atoms, which will bind them together to form the molecules, which is known as chemical bond. Okay, so this redistribution of electrons, which is resulting in a force of attraction developing between the atom, which is binding them together to form the molecule. So this gaining of electrons, losing of electrons, or sharing of electrons, that will create a force of attraction between two atoms of a molecule. Excuse me, two atoms between atoms. Okay, 2 or 3 if it is combining, sharing electrons, then 2 or 3 atoms, if there will be a force of attraction between them, and that will create a binding between these molecules, and this is known as chemical bond. Okay. Now, so the chemical combination of atoms involves the redistribution of electrons so as to leave each atom with a stable electronic configuration. So chemical combination of atoms, what happens, what does it do? It redistributes the electrons so that there can be a stable electronic configuration. Clear? Like two persons know a bonding, when does it happen that the bonding is very strong electrostatic electrostatic force, or you can say strong binding is there when there is complete sharing between the two persons, like feelings, whatever it is, so feelings are sharing, then things also we can share, like that. When this happens, then their bonding becomes stronger. Like that, here also this happens, that when there is sharing or losing or giving, gaining electrons, then the bonding becomes strong. They forms the force of attraction between them, and that will create a bond between them. That is known as chemical bond. Next, we come to isotope. Okay. Now, what are isotopes? Isotopes can be defined as the variant of chemical elements that possess the same number of protons and electrons, but they have different number of neutrons. So atomic number is same. Two atoms having atomic number same, but what is different? Their mass number is different due to the difference in the number of neutrons. Here, the isotopes of a chemical element are a group of atoms that have the same atomic number but different mass numbers. This implies that all isotopes of an element have the same number of protons in the atomic nuclei and the same number of electrons surrounding the nucleus, but they differ in the total number of neutrons present in their respective atomic nuclei. Clear? Like, for example, see, this is the table which is showing the examples. See, hydrogen. Hydrogen has 3 isotopes: protium, deuterium, and tritium. So, first, protium has 1 electron, 1 proton. Okay. That is atomic number 1, mass number is also 1. Deuterium, its mass number is 2 due to the presence of 1 neutron there. Okay, and deuterium has atomic number that is 1. Okay, because 1 electron is there. Protium has 1 electron, 1 proton, no neutron. That's why its atomic number and mass number both are same. Then tritium. Tritium has mass number 3 because of the presence of 2 neutrons there along with 1 proton. Okay, and atomic number is 1 because of the presence of 1 electron. Clear? Carbon has 3 isotopes. One is carbon 12, carbon 13, carbon 14. Carbon 12 has mass number 12, atomic number 6. That is 6 electrons, that is 6 protons and 6 neutrons. Okay. Carbon 13, 13 has atomic number 6, that is presence of 6 electrons, and 13 means 6 protons is there and 7 neutrons. For 14 carbon, that has 6 atomic number, 6 electrons, 6 protons and 8 neutrons. Clear? That's why the mass number differs. Then oxygen has 2 isotopes, 16 and 17. Okay. Atomic number is 8, that is electron is 8, proton is 8, and 8 is neutron, that is 16 mass number. Okay. And for 17 oxygen, atomic number is 8, that is electrons 8, protons 8, but mass number 17, that's why neutrons will be 9. Clear? Then uranium has 235 and 238. Okay. So 92 is the atomic number, that is 92 electrons, 92 protons, and the rest will be the neutron. In case of 238, that means 3 neutrons extra in this 238. Okay. So next we move on to the hydrogen diagram. See, isotope of hydrogen. See like this. Protium. This has 1 electron. No neutron is there. 1 proton and 1 electron. Deuterium. Deuterium is 1 electron, 1 proton, 1 neutron. That makes the mass number as 1 plus 1, that's 2. Okay. Tritium has 1 electron, 1 proton, and 2 neutrons. That makes 1 plus 1 plus 1. That is 3 mass numbers. So this is the table which is showing the atomic number and mass number, 1 proton and neutron number, percentage of abundance, how much it is abundant. Protium how much, deuterium how much, and tritium. Okay. Next is carbon isotope. Carbon also you can see 6 protons and 6 neutrons. The orange is the proton and neutron is the blue one. Green one is the electron. Okay, so nuclear number or nucleon number, that's 12. And here its nucleon number is 6 plus 7, as 7 neutrons are there. So carbon 13, that makes. And then carbon 14, nucleon number is 6 plus 8, that's 14. Okay. So that will be carbon 14. Okay. Next, chlorine, isotope of chlorine. See, this also 35 and 37. So that means 17 protons, 18 neutrons, 17 electrons. Okay, in case of 37, 17 protons, 17 electrons, and 20 neutrons. So mass number varies. Mass number here is 35, and here mass number is 37. Okay, due to the presence of 2 electrons excess. Sorry, 2 neutrons excess. Okay. Now, what are the properties of isotopes? First, we move on to the chemical properties. So chemical properties, they are identical, almost identical, because their atomic number is same. Number of electrons and number of protons, that is same. That's why their electronic configuration is same, and therefore their chemical properties are almost same. All isotopes. So chemical properties are determined by the electronic configuration of an element. As the electronic configuration is same, therefore they will have same chemical properties. The exception in the case is the isotope of hydrogen, because the number of neutrons has a major effect on the size of the nucleus of an hydrogen atom. Okay, in the first in hydrogen one, that is that it has only no neutron, but in deuterium it has a neutron, that's why its size increases, and tritium that size or more increases more because of the presence of two neutrons. So in presence the presence of neutrons increases the size of the uh, atom, hydrogen atom. Otherwise their electronic configuration is all the isotopes electronic configuration is same, and therefore the chemical properties are almost same. Next we move on to the physical properties. Physical properties will vary. Okay, physical properties of the isotopes will vary. These properties of isotopes, a particular element vary from each other. These properties of an isotope depend on the atomic mass or the mass number in the presence of neutrons. So the physical property, why do they vary? Because the physical properties that depend on the different number of neutrons, the number of neutrons, it depends on the mass number or the number of neutrons, and that's why the physical properties of the isotopes vary from one atom to other. The process like fractional distillation, diffusion are used to separate these types of isotopes from one another. The extra neutrons present in the nuclei of tritium, carbon-14 causes them unstable, and therefore the nuclei break up spontaneously. This emits certain types of radiation. Okay, so carbon-14 and tritium, they are radioisotopes. Okay, so the extra neutron which is present in tritium, that is oxygen 3, hydrogen 3, okay, and carbon 14, where hydrogen has two neutrons and carbon has 14, that means here also two neutrons extra. So that means due to the excess of two neutrons here, it makes the atom unstable, and therefore it emits certain radiations, which makes them radioisotopes. Clear? The spontaneous decay of the unstable radioisotope is known as radioactivity. The spontaneous decaying of the unstable radioisotopes, that is radioactivity. Now, what are the uses of isotopes? See, carbon dating makes use of carbon 14, an isotope of carbon. We know that carbon 14 is an isotope of carbon 14, isotope of carbon. So this makes carbon dating. Okay, and this isotope of carbon is present in the atmosphere as radioactive carbon, which is present in the atmosphere as radioactive carbon, and the amount of carbon 14 which is obtained in the fossils by the paleontologists, they calculate the ages of the fossils by this presence of carbon 14. How much carbon 14 is present, that will give the paleontologists the age of the fossil. And that way they can determine the age of the historical or the geological materials. To the fossil's age, they can determine the historical and geological materials. So carbon 14 is used in this way. Next, uranium isotopes are popular for its use in nuclear reactors. In nuclear reactors, they are being used, uranium isotopes. Uranium-235 is used as a fuel in nuclear reactors. Okay. Then radioactive isotopes are used for certain medicinal purposes, like for detecting tumors, blood clots, etc. Like arsenic-74, it's an isotope of arsenic, which is used for determining the presence of tumor. Arsenic-74 is used to determine the tumor. Similarly, sodium-24, it's used to determine the blood clots. Okay. Then cobalt-60, that's an isotope of cobalt that is used for cancer treatment. Okay, then iodine-131, it is used for treatment of goiter. Okay, then other radioisotopes, like they are used in industry to detect the leakage of the underground oil pipelines, gas pipelines, water pipes. Any leakage is there or not, that can be determined from other radioactive isotopes. Okay. So I'll stop here. I'll continue with the rest of the chapter in my next video. Till then, if you have any doubt, please do write in the comment box. Okay, and if you are wanting any test to be done or any other help regarding question answers, any chapter you want another explanation or any other short forms or any whatever subjects you want regarding what I have taught. Okay, please let me know. You can send the chapter or copy of that chapter in my email ID, that is kasturi74@gmail.com. I will help you out. Okay, so no need to worry about that. And if you're liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And if you have not subscribed yet, please to subscribe. And if you have subscribed, then please to ring the notification bell so that as soon as a new video is uploaded, you can be notified. Okay. And please don't forget to meditate before you start your day. So thank you. Thank you for watching and have a good day.